Welcome. Today we're going to talk about this book, A Journey Through the Systems Landscape by Harold Lawson. If you were to take one critical idea from the book, it would be the difference between systems thinking and systems engineering. Lawson describes systems thinking as being where we diagnose problems in existing systems, or we identify opportunities or problems that we want to solve in the environment and build systems for, but we don't actually act. That's where systems engineering comes in. In systems engineering, we act, whether it's building a new system, maintaining a system, or modifying that system. So that's the critical idea that Lawson presents us. He takes us on a genuine journey, hence the name of the book. A Journey Through the Systems Landscape is appropriate. And along that journey, you learn about various different tools or ideas that were important for understanding systems in the wider world, whether that in that systems thinking mode or in systems engineering where we actually act. Now, why should we take Lawson's view as important? Well, he was the architect of ISO 15288, which is the famous ISO standard known as System and Software Engineering System Lifecycle Processes. So very important ISO standard, and it is in fact the one that's various iterations of the INCOSE handbook. So this is the 5th edition here. I think came out in 2023, 24. I forget. 2023. Yes. So this would be based on the version of the latest version of ISO 15288. Okay. Now, if you're new around here, my name is Joshua Sutherland, and on this channel we explore the ideas as to how to make things, how to improve systems or technologies, but also in how to build up teams and things of that nature. If you go on the website, there are a whole load more other books that we've summarized and have been presented here. To do that, all you need to do is go on to joshuasutherland.com/best-systems-books. And from there, I'm just sharing my screen now so you can see what that looks like. There's lots of books here. So Unit X, so this is around a special unit in the Pentagon, which fuses Silicon Valley technology and processes into the Pentagon. Technology management, R&D planning. So this is Professor Olivia DeVeck's book, 2022. So there's lots of books here for you to explore. And all these books, they tend to be, one, they've been highly impactful on my career, and two, they are being very impactful on the wider world. And usually my video will rank number 1 or number 2 on Google in that it has very good content. So if we pick on one here, I've searched how big things get done on Google videos, number 1 there, and that's a long one. 1 hour 47 minutes. So there's plenty of videos there for you to explore, and on the YouTube channel. And there's also the podcast where we interview the authors of these highly impactful books and other things. To get that, you see it on the YouTube channel, but also just go to www.thesystemsengineeringpodcast.com. And again, we have lots of interviews, and I think the Olivia DeVeck interview is now ranking number 2 on Google, and number 1 is the exploration of his book on technology road mapping. Okay, so let's get into things. As with all of these book videos, there is a accompanying PDF that I've created, and you can download this PDF. There'll be a link in the description below. You get it from the website, joshuasutherland.com. It's very easy. You just type in your email address and it emails you the PDF. In this case, it's 18 pages long, so there's plenty of materials. many people say that they like to listen to the audio here, and then they download the PDF and they flip through it at their leisure. So the book itself is quite short. Was that 1.5 centimeters thick, up to about 270 pages. Lots of diagrams. This is the paperback. All of the diagrams are in black and white. There's no color in this edition. If you get the ebook, then it is in color. I don't know if there are printed versions in color. I haven't found one, but yes. So lots and lots of diagrams and things, and so I think it's quite a approachable book for those who are less familiar with systems. And as I said, Lawson was the architect of ISO 15288. He was also the inventor of pointers in software engineering. Those of you who've coded C, C++ will know about memory leaks, and memory leaks are a consequence of not handling your pointers correctly. Okay, so let's dive into the book itself, and we'll follow through the PDF. So if you download the PDF, you can as well. But yeah, that's good. Okay, so part one. What is the central idea or argument of this book, and why does it matter? So it's very important that you develop the capacity to think and act in terms of systems. So I think it's likely, if you're listening to this, that you understand that systems are very important, but this distinction between thinking in systems and acting in them can be not always performed. And it is important in that if we act immediately without sort of thinking, we can likely expend too much resources or make mistakes or cause harm. So thinking, systems thinking is very important for avoiding problems. But equally, if we only did systems thinking, we would never act on the world, and thus there would be no tangible benefits or value created from a particular system. And for those of you sort of unconvinced of the idea of systems, well, we can essentially suggest that the modern world is highly complex, with lots of uncertainty around it, and equally it's highly technology driven, and these technologies are coupled together. So it's quite difficult to think of technologies that are not becoming electrified and not becoming connected to the internet. Even like a fuel station requires electricity to pump the fuel from the tanks under the ground up into people's vehicles, and to do that they use electricity. So even, say, purchasing fossil fuel is highly connected with electricity, and then payment systems, things like that. Okay, so if we take it as it's important to learn how to think and act in terms of systems, essentially Lawson suggests that there will be the following results of that: improved problem solving and decision making, particularly with regard to being able to identify root causes of problems and anticipate unintended consequences and make more informed decisions. Enhanced organizational effectiveness and efficiency. The creation of learning organizations, and this is quite a big theme in the book, in creating organizations that are actively improving themselves and learning from their interactions with the world. And then better management of system life cycles. And the book does mention 15288, which I mentioned earlier, which was the basis of the Systems Engineering Handbook. But he is quite an advocate for following a systems engineering process as described in 15288. In fact, I think there's a whole chapter dedicated to it, and that is understandable given his background. Okay. But then additionally, with regard to those results, Lawson describes how you would end up with a more holistic understanding of the world, and his view is that's very important given the nature of problems that exist currently and where the future lies. Okay, so part 2 of this video, who is the book for and how should you apply it to your work? There isn't a particular reader that is stated by Lawson, but we can pull out places where I think it would be helpful. So leaders and managers in organizations and enterprises, there's a lot of talk in the book around the view of enterprises and organizations as systems, not just the systems they create. Systems engineers and designers, they of course would find it very helpful. And then project managers and wider team members, again, particularly with regard to understanding the context in which their component or subsystem sits and what unintended consequences could be potentially predicted if some effort was gone into understanding its interactions with the wider world. And then more broadly, I'd say anyone who's seeking to improve their problem solving and decision making skills. Problem solving being that diagnostic aspect with regard to systems thinking, and then decision making is essentially that transition from systems thinking into acting, and then acting is actually executing upon those decisions. In terms of how to apply it to your work, I pulled out potentially 4 things. Understanding systems and their interrelationships, improving your problem solving and decision making. So if you do have a problem here, to use the type of tools that are described by Lawson for it, and then applying ISO 15288. It's quite easy to draw the life cycle stages, but of course, it's much harder to actually apply that successfully. And with the this book, it essentially provides you with a bit of guidance in how to apply. Of course, the INCOSE handbook as well is very important. But if you ever dealt with an ISO standard describes what, but it doesn't describe how. Deliberately, it just describes this is what the standard is, but it doesn't tell you how you should apply it. That's for textbooks and training programs and other things like that. Okay. So part 3 of the video, who was Harold Lawson and what role did he play in shaping systems thinking and systems engineering? So Harold passed away, sadly, in 2019. I was due to get him on the podcast, but he passed. He was unwell at the time and couldn't do that. And the book was released in 2010, so towards the end of his career. And I think sort of really rolling up all of his knowledge into a single book. His main experience was with computers and pretty much around that time of what we might consider were the early stages of computing, or where computing was moving away from being a sort of novelty in a research lab and out to having real applications. As I said, he had quite pioneering work in the pointer variable, which is very important in C language, C++ language, and that was all happening in the 60s. And then he had strong leadership in these systems engineering standards. And then in later life, he was a strong advocate for systems thinking and developing learning organizations. And he was based in Sweden. Okay, so part 4 of the book, how is the book organized and how should you read it? I essentially think it's probably a type of book you need to read sequentially, given it's called a journey through the systems landscape. If you were to jump around, you perhaps don't get the full benefit of that feeling that you're moving from one topic to the other. I think the arrangement of the topics has been quite deliberate, and you would be missing out on that. In terms of sort of chapter breakdown, then there are 8 full chapters with content, and then there are several separate chapters which are case studies, and we'll talk about those case studies. So chapter 1, an introduction to systems, which is really those core concepts that you need to grasp. Chapter 2, thinking in terms of systems, a bit deeper into systems thinking. Then chapter 3, acting in terms of systems, and this is where we get that distinction between systems thinking and systems acting, essentially systems engineering. Chapter 4, system descriptions and instances. How do you describe a system, and what's the difference between a systems description and that of an actual real system? Then systems 5, change management. Chapter 6, lifecycle management of systems. So 15 to 88. Chapter 7, data, information, and knowledge, and the difference between those 3 things. And then chapter 8, organizations and enterprises as a system. So it's quite focused. Actually, I'll rephrase that. You can tell that Lawson's background is in software and computers, especially given there's a whole chapter in data, information, and knowledge. But it doesn't prevent you reading it if you're less interested in computers, and given it's quite difficult to avoid having some type of smart computer system in any system, you likely should brush up on these things. And then each chapter has a knowledge verification section. There's an interesting way to describe it, but it's there. And I will just show you an example. This case study. Yeah, here we go. Just go to. Okay, so if you see here, so this is for chapter 2, thinking in terms of systems. And there's, at the end of that chapter, a knowledge verification section. And essentially, it's just got a list of questions that you could ask yourself to check that you understood what was said in that chapter. So, 1, identify some hard systems and soft systems, as well as examples of mixed systems. So that's just one such example. But there's lots through that. So if you wanted to use it as a textbook, you could do that. Okay. So part 5 of the video, what are the key ideas Lawson presents in the introduction to systems? That was the most important chapter of the book, chapter 1. So systems are everywhere, be it natural or artificial. I don't think that's controversial. If it is, please write in the comments and we can have a debate. But yeah, systems are everywhere, and they exist in all fields of endeavor. Often, systems engineers think it's only in artificial, creating new technologies, cars, ships, railways, things like that. But the environment in which we live on Earth has many systems that have nothing to do with humans. The weather system, for example. So, what is a system? Well, Lawson lists some fundamental properties of systems, which are then helpful for you if you were to say, is it a system or not a system? So togetherness is an essential property of a system. It's the interconnectedness of its elements and the relationships between the parts to create a whole new, which is greater than the sum of the parts. So togetherness. Structure. So there's an arrangement of static relationships with the system's elements. Behavior. The dynamic interactions and functions of the system's elements when in operation, and then emergence. So emergence is the unexpected behaviors that arise from the interactions with a system, highlighting that systems often exhibit properties that cannot be explained solely by analyzing their individual components. And So an example I like to use for emergencies, traffic in a city, that each individual car and driver unto themselves contribute a bit to the traffic, but when we completely submerge a city at rush hour, the traffic, no individual vehicle can move, and then there's smog and sort of issues with health, and this is only occurring once all of these different cars start to interact with each other and overwhelm the city's road infrastructure. Okay, so those were the fundamental properties of systems. Then let's talk about the types of systems. So he distinguishes between two: natural systems and man-made systems. I tend to say man-made systems are artificial systems. I get that phrasing from Herbert Simon. So if you've read his other book, Simon's book, Herbert Simon's book, The Sciences of the Artificial, he distinguishes between artificial and natural, so natural science and artificial science. That's a whole other book. You can watch that one at your leisure. But anyway, using Lawson's terminology, we have natural systems. So these are the systems that originate in the universe and are shaped by natural forces and processes, such as ecosystems, weather patterns, and the human body. Whereas man-made systems are systems designed and created by humans, including physical systems like machines and infrastructure, abstract systems like software and languages, and human activity systems like organizations and processes. So some examples of man-made systems in the physical systems, an aeroplane. Abstract systems like software and languages, so Japanese, or a video game, as code. And then human activity systems like organizations and processes. So something like the US Army would be such an example of a human activity system. Okay, system topologies. So it talks about how systems can be arranged in hierarchies or networks, and this is probably best shown as an image. So I'm just going to put that on screen. So if you see here, those of you just listening, I will describe, but move that around. So a hierarchy, think of a organizational chart from the boss down to the managers to the individual workers, whereas a network, think of that as individual nodes that are connected together, maybe like the map of a railway network over a city. That could be an example. You might recognize that, like the London Underground map if you're familiar, or for a different city. Okay, and then other key concepts, multiple viewpoints and views. So think of this as, say you have a system like a railway network. There are different ways in which that different stakeholders would view that system and have different viewpoints that matter. So the civil engineer who's very interested in the structural robustness of the bridges, they would take potentially quite a physical representation of the railway network and how they are, if the loads are being borne by all the concrete and steel. Whereas an economist who's interested in the economic impact of the railway network, they would have quite a different viewpoint with regard to the how much is it going to cost, how much to maintain, but what are the benefits from enabling people to travel. Then Lawson talks about, sort of, do systems even really exist? Because sort of any collection of things can be defined as a system, and are there parts of that system that are added or removed? Does it still stay the same system? You can delve into that if you want, but I think unless you're doing sort of fundamental science, it might not be the most helpful thing for achieving the goals of your system. And then the idea of the system of interest. So that's, typically we will draw a boundary around our system, and anything within the boundary is our system of interest, and everything outside of it is environment. And then we have to interface with the environment. Now, a key theme throughout the book is change and change management. And Lawson talks a fair amount around John Boyd's OODA loop, observe, orient, decide, act, as an example of system change, even though Boyd was describing it with regard to dogfighting in, I can't remember if it was Korean War or Vietnam War. I think Vietnam. So with managing system change, Lawson sort of introduces his own change model, which portrays three essential aspects of managing system change: observing system behavior, studying system situations and responses, and managing system life cycles. We won't sort of delve into the depth of what that is, but I think the idea that Lawson is trying to convey and have the reader take on board is that systems aren't sort of architected once and then done. They evolve and they have to change. And if you think of large infrastructure systems, which at MIT, the Engineering Systems Division, so this other book from Olivier Devec and Roos and McGee, their view is that engineering systems, this isn't systems engineering systems. So an example of an engineering system is like the road network of a major city. These engineering systems inherently have to be evolved. And even some systems that one might think are created once and then sort of just used, they themselves evolve. And so, I have an iPhone here on my desk. Like, this evolves in the sense that there's a lot of software updates that come in, whether they be regard to cybersecurity and patching holes in cybersecurity, or in that case, Apple Computer has determined that a new feature would be beneficial to its users and sort of pushes that out. But also things like the B-52. I think the B-52, the United States' long-range strategic bomber, will fly for 100 years. But over that 100-year lifespan has evolved very significantly. If you look at the early planes, they had like a machine gun turret on the tail, and the newer ones don't have that, because that was built for a time when the bombing aircraft would have to defend itself against fighter aircraft approaching it. Where now, like if a fighter aircraft was going to shoot it down, it would just do that with a missile, and so the machine gun turret would be useless. Anyway, so evolution and system change are very important for Lawson, and hence he mentions them a lot. Okay, so part 6 of the video, what is in Lawson's system survival kit, which is towards the end of chapter 1. Okay, so I'll just leave that on screen. So there's a large table of definitions on which are grouped into some core categories. So the concept categories, so I mentioned before what are the core concepts around systems. So togetherness, and he has his definition of togetherness there. Two or more elements that are related, resulting in a new whole. But there's a whole load of other definitions. There's then this universal mental model, which you can use universally, as it says there, for different system situations. And the sort of key ideas within that universal model, you have system assets, which are the resources and capabilities of an organizational process. Situation system, so this is the problem or opportunity that needs to be addressed. The respondent system, this is the system created to respond to the situation, often drawing on system assets, and then the control element, which is the crucial part of the respondent system that directs and manages the operations. And so the diagram highlights the sort of dynamic interaction between those elements. And yeah, Lawson states that this is a universally applicable model and one that you should apply to your work. Yeah, and I think it sort of, to me, is this dichotomy between the systems thinking and the systems acting. And the thinking, the acting come together. He doesn't mention this, but to sort of produce value. And then he has within the system survival kit, the systems principles, of which there are 13. Wow. They're not chunked in any way. He's just got a big old list. 13 system principles. We can go through them, and I'll pull out any that I think are of particular interest. So 1, all systems are composed of 2 or more elements that constitute togetherness. Okay, that doesn't sound controversial. 2, systems are composed of structural elements or behavior elements. I'd have thought that might be an and or, but okay. 3, defined elements and relationships can be abstract, physical, or human activities. 4, systems are organized as a hierarchy or a network. I would say that might be a bit of an and there as well. We can think of many things where there's a network and there's hierarchy, but anyway. 5, bounding of systems in respect to the views are defined by a narrow system of interest, a wider system of interest, their environment, and the wider environment. So this is sort of a nesting of what is of importance to you and your particular system. 6, complexity can be reduced by the identification of essential factors, be it concepts and principles. 7, complexity is addressed by proper organization in describing complex behaviors. Those of you who are sort of interested in the whole uncertainty and whether you can even, are you dealing with a type of uncertainty that can be characterized, or a complete sort of unknown and you have no hope with? 8, complexity rises when systems are disorganized, resulting in random behavior. 9, people have various perceptions of complexity, as well as potentially participating in a system resulting in the addition of complexity. 10, situation systems result in problems or opportunities or defined objectives in the form of end states. 11, respondent systems are developed and utilized to handle situation systems. 12, sustained system assets are instantiated and deployed in respondent systems. Instantiation, so yeah, a bit of computer science language there. And 13, one of the elements of a respondent system must provide control. So they sound reasonable. I think they could be doing with cut down a bit and maybe chunked up a bit. So I think if this system survival kit is helpful, I would say mainly in the terms of the definitions and the universal mental model. I think, as I said, I think if the left-hand side was more about systems thinking and the right-hand side systems acting. System principles, yeah, I think this could be a little bit more accessible. Right. So on to part 7 of this video. What is thinking in systems versus acting in systems? And I made quite an extensive table for this, which you can download in the PDF. I think you'll find it quite helpful. And I at least find when comparing and contrasting, let's say, two things or three things, having a table and then the various elements that are, essentially the characterizations of them by these different elements to be very, very helpful. So this is the critical distinction. As I mentioned, right at the beginning of the video, if you can get into your mind this idea of thinking systems and acting in systems, I think you're long on the way to understanding what Lawson was trying to convey. So thinking systems. What is the focus of thinking in systems? It's observing and understanding the dynamic behavior of systems. Observing, that's the key word. The dynamic behavior of systems, particularly in complex interactions between multiple systems in operation. So observing, looking at stuff, you're in a telescope, seeing things. What is the focus of acting in systems? So this is the creating the structures and of systems to achieve desired outcomes, improve existing situations. Okay. What is the goal? What is the goal of thinking in systems? The goal of thinking systems is identifying underlying problems and opportunities by seeing wholes, interrelationships, and patterns of change rather than static snapshots of situations. What is the goal in acting in systems? Making tangible changes to system descriptions or operational parameters to improve system behavior and achieve desired effects. So it might be worth, while you're right now, have a think, what are some examples either from the news or your own life, your own work, where thinking in systems and acting in systems were distinctly different activities, but were beneficial when they were. I mean, I'm just thinking right now of the story of a company like Tesla, the electric car company by Elon Musk. There was a lot of thinking in systems with regard to the inefficiency of the internal combustion engine as just a sort of oil well to the wheel, moving the wheel of a vehicle, and all of the inefficiency in doing that versus what they were seeing with the improvement of energy density of batteries and the inherent higher efficiency of electric motors. So that would be, in my view, an example of phenomenal thinking systems. But then the acting in systems was when they were to build their prototypes, to design their production vehicle, to build their production system. That would be acting in systems. But I think you should, in your mind, think of some others, and please do write them in the notes in the comment section, and I'll be very interested to hear of your thoughts. And if you disagree, like all of this stuff, all of it is up for disagreement. So please do. We like the debates, or I do. Okay, thinking in systems. What are some tools of thinking in systems? The tools that Lawson provides us or describes are 5 whys analysis for uncovering root causes. This is a sort of Toyota thing, Toyota production system. So if something goes wrong, why did that happen? Okay, so if something goes wrong, somebody falls over, why did it happen? Because they tripped on the wood that's on the floor. Okay, why is the wood on the floor? Because the pallet that it was loaded on split. Okay, why did that happen? Because the pallet was only rated to take 1 ton and we put 2 tons on it. Okay, well, why did that happen? Oh, because nobody knew that the pallets had this weight limit. Okay, well, why did that happen? Oh, because our forklift operator didn't take his forklift exam. So that sort of multiple stages of why, you can then just uncover the underlying root cause. And I was just making that one up about the forklift truck. But you then address the root cause such that other potential problems won't be you'll be mitigated into the future. Okay, let's rack up the other examples of tools used for thinking systems provided by Lawson. Influence diagrams for mapping causal relationships. Links, loops, and delays language for depicting feedback and dynamic behavior. That sounds a lot like system dynamics to me. I don't know if he's talking about the same thing or if that's different. I'll look that up. Rich pictures, and that's spelled with a capital R and a capital P for visualizing complex situations. Systemograms for graphically representing systems. Simulation tools like Stella and iThink for quantitative analysis of dynamic systems, and soft systems methodology for addressing human activity systems. Then acting in systems, what tools do we have? Essentially, this is ISO 15288, and I would then expand on it and say, and the INCOSE handbook, that's a big contributor to acting in systems, particularly systems engineering. But you could, the whole industry of how to design and make stuff is vast, and lots of competing, or maybe competing is not the right word, complementary tools and techniques for doing that. Okay, and then, so thinking in systems, just to summarize, it's all about the diagnostic aspect of the systems work, understanding how systems behave and interact, whereas acting in systems is the action base, and it's based on the insights that we gain from systems thinking. So hopefully that was understandable for you. If it wasn't, please do contact me and we'll sort that out. Part 8 of the video, what are some key topics from systems thinking? I think the key idea was understanding systems as a whole and their interconnections. And that's additionally, if you then want to move into what are some patterns that can occur repeatedly that you might discover with your systems thinking work, dynamic behavior and particularly feedback loops. And ideally you want feedback loops that are moving your system in a positive direction, but of course we have negative feedback loops that cause things to go wrong, get worse and worse. And then emergent behavior and unpredictability. Key topics from acting in systems, this is part 9, key topics in acting in systems. So 1, systems engineering principles and processes, and the life cycle management, in particular the ISO 15288, and the importance of defining system requirements and the architecture up front, and then use that to build the actual system. And then on the change management and continuous improvement, this is where Lawson talks a fair amount around John Boyd's OODA loop, observe, orient, decide, act, and then PDCA, which was Deming, if I remember rightly. So plan, decide, checked, act. And so these cycles of continuous improvement are very important for Lawson. Okay, so that's all been very theoretical. What do we have in terms of case studies in this book? So the case studies are, I would say, a little light on the types of artificial systems that we tend to think of with regard to systems engineering. So like on the cover of the INCOSE handbook, we have an aircraft, a satellite, electricity pylon, a road network, and some shipping containers in a operating theatre in a hospital. Okay, well, the examples in A Journey Through the System Landscape from Lawson are crisis management, and particularly the creation of SWAT teams, special weapons and tactics, which is sort of generalized to mean special response units. So special units within police and law enforcement that are much more heavily armed and take down terrorists and things within a sort of domestic setting. So there's an example. There's a full chapter dedicated to this regarding using a system-oriented methodology to analyze these SWAT teams as a complex system and examining the factors that contribute to their successes. Organizational development of a bank, and how essentially Lawson presents a analysis of the bank's decentralized structure and sort of visualizes its culture as a complex system. And then automatic train control. He describes the architectural concepts that have made this particular train control system for the Swedish railways very, very successful. And then a dentist oral medicine web project to make an ontology for them. So it's quite a variety of case studies, which is good. I think they probably should have been arranged where the initial one on the SWAT teams feels like probably a bit advanced to be the introductory case study, but that's the way it is. Okay, part 11 of the video. What is the importance of change management to systems? And I've got 6 points here. So adaptation to the evolving needs of the environments. So you build a railway line, and then the weather. Essentially, you build a railway line through the mountains, and the snowfall is different than you were expecting, and you then need to evolve your system to meet that new environment or the needs. Let's say a lot more people want to travel than were predicted, and so you need to expand the capacity of the railway line. 2, you need a controlled and reliable implementation of changes. And so that's why change management is important. 3, gathering knowledge and improvement, and that you've got new knowledge in, and therefore you should use that knowledge to improve your system. Managing complexity and interdependencies. That was 4. Then 5, enabling innovation and continuous improvement. And 6, addressing both structural and operational changes. And I've written this in bold. Change management is the engine that drives system evolution and improvement. And as I've said, in MIT engineering systems, that really emphasize this need for evolution, and the large-scale systems really do need to be evolved. So what is life cycle management? I've been talking a fair amount about Lawson's background as the architect of 15288. It's essentially a comprehensive approach for managing the systems through their existence. Generally, the life cycle stages would be one of concept, so defining the system's purpose, goals, and requirements. Development, so designing and building the system. Production, implementing and integrating all those system components. Utilization, operating the system and delivering its intended needs. Support, so maintaining and enhancing the system. And then retirement, so decommissioning and disposing of the system, which, depending on the system, that can be an incredibly difficult and important thing. Think nuclear power stations. Decommissioning nuclear power stations into itself is an incredibly major project. Right, so then I mentioned earlier that there's this chapter on data, information, and knowledge. And you might think that's a bit odd, given the title of A Journey Through the Systems Landscape. And so here it is, data, chapter 7, data, information, and knowledge. So that exists. It is a major chapter. Why is it here? Well, it appears that society's trajectory is such that more data is being collected and processing of the data is becoming cheaper and cheaper, and algorithms are able to do things that we felt science fiction only a few years ago. Think these large language models, ChatGPT being one such one. So in fact, this book was written in 2010, and I'm recording this in 2024, so 14 years ago. It does seem that Lawson was maybe a little bit ahead when dropping this in as a whole other chapter. So let's first we'll get an understanding of how Lawson distinguishes between data, information, and knowledge. So data is the raw, unprocessed facts, numbers, that's it. So 18.5, okay, that's data. And maybe you get another data reading out 20.1 and then another one, I don't know, 17.2. So it's just a number. Information is where the data is being sort of processed and organized. And so it's at that point we might add to those numbers degrees Celsius. So 18.5 degrees Celsius. That is information. Previously, when I just said 18.5, that is just data. And then knowledge is when we actually use that information and actually, I'm not going to say use. We connect it to a broader context. So if I say 18.5 degrees Celsius, that's sort of fairly room temperature. And people can convert that into Fahrenheit. I can't do that in my head. And so that's where it becomes knowledge. And so Lawson is very places great emphasis on the difference between data, information, and knowledge. And he doesn't say this, but I think he's sort of indicating that we can gather lots and lots of data now, and we can convert much of it into information, but turning it into knowledge and that knowledge being truly useful is very hard. Maybe large language models, advanced AIs are massively improving that, absolutely, and maybe that should be our goal. He then talks about the organization of knowledge and the distinction between taxonomies and ontologies. I won't sort of go into all that detail, but essentially taxonomies is hierarchical classification of data, and ontologies is a broader term. Taxonomies is a type of ontology, a way of managing all that data, which is important. And actually, I was thinking we should at some point do another book. Yeah, maybe at some point we'll do this book, information anxiety, and sort of the challenges of. If you want this book, let me know, and we'll do this. But yeah, how does in an age of vast amounts of data, how do humans best respond to that? Okay, so some concluding thoughts from Lawson. I mean, his final chapter is on organizations and enterprises as systems. This is quite interesting again. I think it's potentially him sort of looking to the future, and that artificial systems or hard artificial systems being less and less the place of importance where the human mind is best most needed, and in fact sort of more these organizations and enterprises is where the real work is, and sort of the manager of that organization is the systems owner, and he talks about how the organization's goal is to, well, not the goal, but an important aspect of the organization is counteracting entropy, that's sort of trying to pull it apart and make it not functional. and that continuous improvement is the antidote to that. Using PDCA, things of that. Okay, so part 15 of this video, concluding thoughts. As I said, that key distinction you need to have in your mind, the difference between thinking and acting in systems. The key takeaways from the journey I would have as being system thinking provides a holistic view. It helps us understand organizations as complex systems with interconnected parts working together to achieve a common goal. We need to recognize the difference between data, information, and knowledge. And this is important for decision making and system evolution. Organizations can be viewed as a system of interest, which you're acting on, and that learning organizations are very, very important. The benefits that we can take away from taking that systems perspective, we can make more informed decisions about system design, improvement, and change management. We can identify and address issues that we have detected. We can foster better collaboration, and we can create more resilient organizations. So, as I said, if you want the notes, there's a link below. It's 18 pages PDF. You'll get it directly. Just click on the link and you'll get those. Other housekeeping stuff. So if you're watching this in December 2024 or listening, there is a giveaway right now. You can get I'm giving away free, as in numerical free, copies of Unit X. You can get them, get one of them. All you need to do is leave a comment on the Unit X YouTube video. You'll find that on the channel. It's very easy to do. And as I said, actually, if you just Google, Google, Unit X, how the Pentagon and Silicon Valley are transforming the future of war under videos. Yeah, my video is number one. We're outranking. That's the Sun newspaper, which is a pretty major British newspaper, and we're beating them, which is good. Go on that. Leave a comment, and the best free numerical free comments will win a copy. I've got a stack of them in my office now, so I look forward to all of you competing in that. Other housekeeping things. Go on the joshuasutherland.com/best-systems-books. Loads of other summaries and key ideas from very important books there. Bent Fluvia's book on how big things get done. This is based on, they analysed 16,000 different mega projects at the University of Oxford, where Fluvia was a professor of economic geography, actually. And this has been very, very, a lot of people are very interested in this, and it's very good. And all of these books have their own PDF summaries that you can get. You just click on it and you get it. So you should all go on this page. And you should also, if there's a particular piece of content you want one of these videos on, we've done now Journey Through a Systems Landscape. There's a whole series of these ones with this similar design. We can do that. Just let me know. Okay, so looking forward to hearing from you all, and I'll see you soon. Goodbye.